So as Leonel said, my name is Hussein, and I'm working as a statistical engineer for L'Oréal Research and Innovation. And today's talk is about the model that we have built for predicting the quality of a knowledge elicitation session. And this predictive model has been elicited. That's why we have assigned it as a kind of meta model, because it's an elicited model to predict the quality and the success of an elicitation. What is elicitation? Elicitation is a methodology for creating causal and graphical models thanks to the extraction and the formalization of expert knowledge. So the implicit and non-material knowledge of experts are made explicit and digitalized. In reality, the product of an elicitation is not necessarily a causal model, but here, in this case, we talk about elicitation of causal Bayesian networks. In this case, so in addition of experts who will participate to the construction of this model, we need also a modeler to define the structure, and the facilitator, who is the intermediary between the expert and the modeler. This approach of elicitation of causal Bayesian networks provide lots of advantages. First of all, from a methodological point of view, it allows for the researchers for a complete change of a paradigm because it is based on causal reasoning. We know how to act on an observation to modify its consequences. The second point is that it's an hybrid approach in which the expert gives the meaning to the data he or she is going to exploit and acquire. So at the end, the object has a sparse character. Among all of the possible dimensions of a problem, only the ones that make sense are retained. And finally, for sure, the result is graphic. So it is not a black box, and it enables the researcher to exploit it very easily and to update it easily also if needed. Elicitation can be really key for companies. It can to have, I don't know, maybe predictive models. It can be also for decision making or for capitalizing on the know-how of the expert. But lots of challenges has also to be faced when we are doing elicitation. And I will explain how we have been able to elicit a model for assessing the probability of success of an elicitation. And so after some context element, I will detail the choice of the structure and the different dimension of the meta model that has been built. So elicitation of causal Bayesian networks require, as I said, a given number of experts who are gathered. Those experts give them knowledge to build a model structure, and for each node they also give the prior distribution. So the sessions can be really time consuming for the expert, for the modeler, for the facilitator, and without being 100% sure that at the end we will have a model with a good quality. In addition to that, so the experts are sharing expertise, they are sharing their knowledge, they are confronting their point of views, and controversial discussions can also happen, and the reputation of people can also be affected. And finally, it can also be cost effective, especially if the company must pay for external partners. So considering all of this in a context of multi-management and prioritization, a tool to decide whether an elicitation can be useful is really interesting for evaluate priority of a project and the feasibility of this project. And this is the main topic of this talk. We will present how we have elicited a Bayesian network to help experts and the management to prioritize elicitation projects. So during this presentation, I will use the term meta model to talk about the Bayesian network that is presented here. And I will talk about a model to talk about and given elicitation model that a team in a company would like to elicit. So first, we have identified which meta model structure has to be used. So we knew that the output is the probability of success of an elicitation session. But as preliminary brainstorming, we have seen that lots of parameters can impact the probability of success of an elicitation. But a meta model with all inputs connected to the same output is not reasonable. Indeed, the probability table of outputs grow exponentially and as a function of the number of parents that are connected to this output. And for a human brain, it's not possible to elicit probabilities with such a large number of conditional probabilities. As an example, here we have an output that has 2 states, which is connected to 4 parents that have 3 states each. And only with this simple structure, we have 162 probabilities to elicit, which is not reasonable for a human brain. So we have done what we call a diversing structure. This structure solves the high dimensionality problem explained before. Each input nodes are connected to what we call an impact node, and those impact nodes are elicited by the expert. And then all of the impact nodes are combined little by little and then connected to the output node, which is the probability of success of the elicitation. Each impact node is considered independently of the other input. This is what called the assumption of independence of causal influences. So this is a very strong assumption that is a simplification for sure of the reality. But in a context of an elicitation, it can be a parsimonious statement in order to go forward and to define a model that is more simple. So we have defined diversing structure, but we have to define what are the different combination functions that we have to apply to those impacts in order to gather them little by little. So how can we define a combination function? It depends on the problem. Here, it's not a model where each node gives information cumulatively little by little. Indeed, here we need to have necessary conditions for the model to be used. Indeed, if, for example, a team in a company would like to do an elicitation for a model, and they don't have experts for this field, then the probability of success should necessarily be low, no matter the other dimension of the elicitation condition. It has to be low, but not necessarily equal to 0. We need to keep the uncertainty on the probability of success in case here, for example, if we don't have expertise in the field for which the team would like to do an elicitation. So the combination function that has been identified here, and which is most optimal one, is the noisy end combination function, because it has the property of necessary condition while keeping the uncertainty. And here is other examples of combination functions that we have deep dived also. So we have, for example, the noisy OR function, which has the property to have what we call sufficient conditions and not necessary conditions. So at least some condition needs to be verified to have a good probability of success. It is less conservative than the noisy AND function, and it's also a combination function that can be very interesting for the meta model, but it's not the optimal one. And we also have deep dive the model with the additive impact model, so where the combination functions are the sum of each impact, but it is also less conservative than the noisy OR model. And in order to apply also a sum on the impact, we need to define a scoring system of our impact, which is also not really easy to define according to the nodes. So we have defined the structure, which is a diversing structure. We have defined the combination functions that will be used, which will be the noisy end combination functions. Now we have to identify the different dimensions of this meta model. And those are the different dimensions that I will present in this presentation. So in order to have a good probability of success, we need to, first of all, assess whether the experts are prepared and trained before the elicitation session. Then we have also to evaluate the quality of the group of experts. Then we will be able, with those 2 dimensions, to evaluate the conditions of the elicitation session, so when the people will be gathered together. And with the conditions of the elicitation and with the modeler experience, because we have had the modeler in the model, because if you don't have a modeler in your elicitation sessions, then you can't model anything. So by having the condition sessions and the modeler, we are able to evaluate the model quality, which is a function of, which is linked, to the probability of success of an elicitation. So those are the main dimensions. They are not the only nodes that are in the model. I will detail the model after, but those are the main dimensions: the preparation of expert, the existence and the experience of a modeler, the quality of the group, the elicitation session conditions, and the model quality. So the first dimension is the preparation of experts, and if experts are trained or not. This is what we have called the pre-brainstorming. So it's all of the prerequisites to prepare experts and facilitators to the exercise of elicitation. So it is defined as if experts are trained, if we have seen them before, to explain them what is an elicitation, etc. So this is the first dimension, which is called the pre-brainstorming. The second dimension is the group quality, which is the function of the group cohesion, the level of expertise of the group, and the group size. And yeah, I will not detail exactly each node, but this is the main things to understand for this group quality. So group size, level of expertise, and global cohesion and motivation of expert, and if there is also conflict of interest of people. And also we have identified that the presence of the expert during the sessions is also something that is very important, because people that are here one day, then they never came, then they recame 2 weeks after, it can be very difficult to have sufficient conditions to do an elicitation. And finally, so the pre-brainstorming and the group quality are linked to the project overall conditions with other nodes that are related mainly to the session itself, like the format, if we have days of elicitation or half days of elicitation, the spacing of sessions, if between the different sessions we have 1 week, we have 3 months, we have 1 year, and if also the question is clearly defined or not. So all of those things participate to the project conditions, to the conditions of the elicitation session. And the condition of elicitation sessions and the modeler experience are two nodes that are linked to the final model quality of the elicitation session. And then finally, the probability of success is a direct function of the project condition, the model quality, and something that I have not talked yet, the data. Indeed, I was talking about model quality, but I was talking about probability of success, but it's not really easy to define what is a success of an elicitation. And the success mainly depends on the objective of the elicitation. So I have here represented the different successes that we can reach with elicitation sessions regarding a usage scale. So an elicitation, the success can be just for the team building, so just for knowledge sharing. It can be also to have a model but only used by expert. We can also have an elicitation session to have a model that is used by everyone, not only the experts that have built the model. And the most used in the usage scale of success is the automatic exploitation. So if we have a model that is industrialized in, I don't know, an assistant, a device, or I don't know what. So finally, even probability of success is not really easy to define for an elicitation session. And that's why we have split it into according to the objective that we would like to reach at the end of the sessions. And this is the final model with everything connected and with all of the dimensions that I have presented before. And now this model is included into the web simulator, and it will enable us also to talk with the experts before the elicitation session using this model to evaluate what is the chance to have a success for an elicitation. So thank you very much for listening to me and listening for this presentation.